All right, so this video is going to cover just some of the basics for plumbing pumps. So, um, just in general, there's lots of different types of pumps. So, when we talk about construction systems and general building usage, we are talking primarily centrifugal pumps. So, there's a lot of different types of centrifugal pumps that we use. There's a lot of different applications for them. The primary one that we would have would be an end suction pump and then vertical inline. So end suction would be like your main feeder that are bringing the plumbing, any of the domestic water, and some other systems too, into your building, and then distributing it out to the different branches throughout the facility. And your vertical inlines are heavily utilized as well, but those are more for maintaining that pressure and balance throughout your systems. We also have different types of centrifugal pumps like split case and vertical turbines. Split case for much bigger applications, and vertical turbines are a little bit more for like a well pump or something like that. And then some other types that we have would be submersible that we use a lot of times, and then positive displacement as well. So there's a lot of different applications for your centrifugal pumps. They are the most commonly used in a lot of different configurations and fashions. Pretty simple, pretty straightforward. They're just like a centrifugal fan. So when we talk about that in air, in our airflow portion of this course, they operate in a very similar fashion. So we basically have three major components to them. We have an impeller, we have a casing, and a driver. The impellers are that portion that rotate, that actually pump the liquid. Thinking like a boat propeller. Your casing is something that converts that velocity into that controlled pressure to stabilize the flow. And then you have a driver, which is that electric motor, usually gas or steam powered. So different types of centrifugal pumps. The one on the left here is a volute. This one is probably the most common that you would see throughout, as opposed to the diffuser type that's shown on the right here. But as you can see, we have a couple different pieces. On this one, if this was an end suction, right here is where we would have the inlet coming in for wherever the water is coming from, and then we'd have these impeller blades spinning around, distributing, balancing out the water pressure in the system, and then the pump eventually hitting this cut water piece and the discharge pipe and sending it out into your different branches. Here is a picture of what some typical main pumps would be in your building. So you'll see these for a lot of different types of systems. Again, I'm just talking about domestic water, but you'll see these for, like fire suppression pumps and others as well. That little portion I just showed you is this end suction piece right here, where you'd have water coming in from your main feed, hitting your pump, getting dispersed, and then getting sent out across your distribution system. And this portion over here is your motor. So again, your end suction is the most common. It's a large range of applications. We use it for a lot of different things. You'll see them all over your building for different reasons, or multiple different types of buildings, I should say. Very simple design, relatively inexpensive, relatively efficient. And it's pulling that liquid from one end, liquid coming in to displace it and discharge it all throughout your facility. Well, vertical inline is very similar in design to an end suction, except for instead of having the liquid coming in from one side and then distributing it in a different direction, it's actually just directly in line with the piping. So very small applications used to save on floor space. You can put them on really small pipes, and they're really used to maintain that pressure and balance throughout your facility. So as you get further and further away from your main distribution pump, you lose pressure. So you want to make sure that you maintain that pressure and boost it all throughout your facility, so you have water pressure everywhere. So here's a quick picture of how it would look. We would have one side your inlet, on one side your outlet. So we'd have pipes on either direction of this, and then you have your centrifugal motor in the middle that's redistributing the water. For horizontal split case, These are also called double suction impellers. They're also called between the bearings, since there's two bearing plates on both sides. So these are not end suction. These are a little bit more of like that inline. They're a lot more robust and durable, and they're used for a lot higher flow applications. So bigger industrial plants, larger scale, commercial, that kind of stuff. Here's what it looks like. So instead of having an end suction where liquid would be coming in from one of these directions and then being distributed out in the opposite direction, this would have an inlet in one way and an outlet in the other way. So we have the double impellers here. We have the two bearing plates on each side. So these are, again, used in much bigger applications. Your vertical turbines are a little different too, only more common for like a well application, different types of water treatment facilities, things like that. So if you're doing heavier industrial plants and you guys are, and you're grading or you're pumping wells, you'd be using a vertical turbine type system. Whereas these would be, so again, similar to your end suction where you have liquid coming up in one direction, getting pushed out the other way, just in a different configuration. And then you have submersibles as well. Submersibles are typically another type of centrifugal pump. Main function for these to pump different water sewage out of a space. We use them for like lift pump stations. We use them for temporary dewatering systems during construction. We use them for permanent structures where we have high water tables or any place that's prone to flooding. Anything that can be submersion liquid. So like example would be a sump pump in your house. So if you have one of those, so this is, again, it's like an end suction, but this pump would be designed to actually discharge any kind of liquid that's built up. So these are designed so that once they sense any kind of liquid in the pit, they would be sucking in the moisture and then discharging it out. When it comes to positive displacement pumps, we have a couple different things that we have to look at. We have a suction side and a discharge side, just like anything else. These are a little more complicated because we have an expanding and a decreasing cavity for them. I'll jump ahead here a little bit to get to a picture so you can see what we're talking about. But liquid is flowing in from as the suction side expands, and then it flows out as the cavity side collapses. So we have two different types, reciprocating and rotary. I don't go into too much detail on this because these are more for different types of process applications. They're not as much of like the common type of plumbing pumps that we would use in our general systems, although you'd still probably or oftentimes see them in different capacities. So your reciprocating ones are either usually a plunger, a piston, or a diaphragm type pump, usually for more smaller application or smaller volume, high pressure application systems. And these work kind of like a bite pump. As opposed to a rotary, which one we have many different types. Things like screws or gears or lobes are pretty common. These would have a fluid that's sort of entering into a rotational mechanism that creates that pressure and pushes the fluid through the output. So these are a little bit more used for like a higher viscosity, larger industrial applications. So the reciprocating one over here is an example where we have a crank that's turning and this piston's moving back and forth, and as it's moving back and forth, it's pumping water in and out. As opposed to a rotary over here, we can see we have some sort of suction that comes in, and this lobe type over here would be rotating in this direction. This one would be rotating this direction, is creating the pressure and forcing liquid out and around into the discharge pipe. Very similar applications for these other ones that are like gear types or vane types. Last thing we'll cover here is pump measurements. So pumps are measured in a couple different ways that you'll see: flow rate, capacity, and then feet or foot of head. I've seen it in multiple different ways. So what flow rate means is basically that is the velocity. It's typically measured in GPM or other units per minute, whatever that might be, depending on what you're measuring, what type of fluid you're dealing with. Your capacity is the total amount of energy that is required for a pump to move a specific amount of fluid. So it's not just how much is moving, it's a specific amount and over a certain amount of time usually. And then feet or foot of head measures a vertical distance required to pump a fluid. So there's a pressure differential that takes place between fluid and specific gravity. So as we're pumping liquid from our main pump into our buildings, we need to know how much vertical distance we have to go because gravity plays a big role. It's also called head lift. I've seen that many times as well. The other thing to note on this too, just for generic understanding, is inlet and outlet sizes are also important to know, just because of the fact that if we have incorrect sizes, there is a pressure balance and overall capacity issue. So things for like retrofitting and adding capacity or removing capacity, you want to maintain the balance within our water distribution system. And with that, that is a brief intro into pumps.